This is Algebra 2, Lesson 1.5, Homework Solutions. I should probably write solutions then. In number 1, we're asked to write an equation of a line that passes through these 2 points. The equation of a line, typically speaking, is going to be in this slope-intercept form of y equals mx plus b. We need to find m and b, and then we're done. So I'm going to, and I can actually find b right now, but usually I always start with slope, and I'm going to always start with slope, even though I could do b in this case. So in order to find slope, m, or the slope, is going to be the change in y over the change in x. So I'm going to ask this question, how much did I change in the y-coordinate? And that's between 7 and -3. Well, to get from 7 to -3, I had to go down 7 to get to 0, and then down another 3 to get to -3. That's a total distance of going down 10 or minus 10. How much did I change to get for the x's between 0 and 1? Well, to get from 0 to 1, I just have to add 1. So those are the changes. My change in y is minus 10, and my change in x is plus 1. If I simplify this fraction, I just get -10. So there's my slope. Now I have the second iteration of my equation, which is y equals -10x plus b. The only thing left to do is to find that value of b. The way I could find that b is by using the definition of what the y-intercept is, because b, again, is just the y-intercept. The y-intercept is whenever you have an x value equal to 0. If we had a point where the x value was 0, we'd be done. And in fact, we do in this case. When x is equal to 0, when it's 0, then the y-coordinate is 7, which means b is equal to 7. I'll say b is equal to 7. And my final equation is y equals -10x plus 7. And I boxed my work. Number 2, write an equation for the line shown in the graph. Again, we are going to be using slope-intercept form, so this is going to be y equals mx plus b. And the first thing that I'm trying to find is slope. M, again, is always the slope, which is the change in y over the change in x. So the change in y, let me go ahead and find some lattice points. Lattice points is a fancy-pantsy way of saying I go through the crosshairs. So this is a lattice point, this is not a lattice point, this is not a lattice point, but this is a lattice point. My 2 lattice points are here, and I have a few others here and probably right there. These are all 4 potential lattice points. The closer your lattice points are together, the better your answer is going to be without reducing a fraction. So I could be making a triangle that looks like that, but I'm going to choose points that are closer together, and I'm going to do ones that look like that. I went down 3 and I went right 2 from this point to this point. You could have moved from the right to the left, but in English we read from left to right, which is the reason I typically always go from the left point to the right point. I went down 3, then I went right 2, which means my change in y in this case was down 3, and my change in x was right 2, and this fraction is just -3/2. All right, and then to find my y-intercept, this y-intercept is wherever I cross the y-axis. So the y-intercept is the cross of a y-axis. In this case, I cross the y-axis right here, which is unlabeled, but it is indeed a y-axis. I cross it at this height of 1. So this 1 is really our b. So I'll label this y equals -3/2 x, and then plus 1 for our final answer. All right, and number 3, the y-intercept of the graph is 0, y. What is the value of y? Well, that's a great question, and you can figure that out really quickly. So I'm going to go through the more thorough definition. So to find the y-intercept, by definition, I'll say this: y-intercept is when you have x is equal to 0. So what, and this is even saying that, hey, my x-coordinate is 0, and I don't know what my y-coordinate is. What I'm going to do is I'm going to plug in 0 into this x. This is going to be a number that will be our y value that we're looking for. This y value and this y value, in this case, are the same if this 0 is plugged in for this x. So I'm going to rewrite this. I'm going to say y is equal to 2 times 0 minus 4, and this is going to be y is equal to 0 minus 4. Therefore, our y-coordinate is -4, and you get your final answer. However, there was a much faster way of doing this, which is just to analyze our slope-intercept equation. The slope of this equation is 2. The y-intercept of this equation is -4, and just by looking at this equation without doing any of this work, I could have told you that the value was -4. And number 4, the table shows the linear relationship between x and y. Write an equation for the relationship. All right, well, we need to have some sort of y equals mx plus b to get this set up, and to find m, this is going to be the change in y over the change in x. So I'm going to choose two random numbers. I'm just going to choose those two, and we'll see what happens. To get from this x value of 0 to this x value of 4, I went plus 4. To get from this value of negative 22 to this value of 22, I had to go up 24, rather to the right 24. Why 24? Well, I had to go from negative 2 to negative 1 to 0, and now that I'm at 0, I go another 22, so it's a travel distance of 2 and 22, or a distance of 24. This is the change of the y, which means 24 is a change of 24 is a change in y, and 4 is a change in x. This reduces to just 6. Next, we need to find what the y-intercept is. This definition of the y-intercept, yet again, is where the x value is 0. Which of these x values is 0? Right here, which means the y-intercept is negative 2. So I can write out the final equation here. Y is equal to 6x, that was our slope, 6x, and then minus 2 for our final answer, which I can then box. Now we're moving on to number 5. After the school pep assembly, the student council helps to crack or stack the chairs. I cannot read right here. The total height in inches h of the stack n chairs can be modeled by that equation. A stack of chairs must include at least one chair, and we're going to complete the table. So to complete this table, what I have to do is I have to plug in n values to this n value right here. I'm going to plug in 1 to this n value over here. So if I do 1 minus 1, then I get 0. This value is 0, so 5 times 0 is 0, and 0 plus 30 is 30. So for each of these, I'm plugging in values. So I'm going to even write out my work instead of just doing it in my laser pointer. I did 30 plus 5 times 1 minus 1, which was 30 plus 5 times 0, which was 30. Next, I'm going to plug in 2. I don't have to. This is the long way of doing it, but I'm going to show you the long way of doing it just in case you forget the pattern. The long way of doing it is doing the same thing again. I'm going to rewrite my equation. 30 plus 5 times, instead of 1 minus 1, it's going to be 2 minus 1, because this value of n is now 2. So over here, I'm going to have 30 plus 5 times 1, which is going to be 35. And over here, I get 35. And at this point, it's worthwhile showing you the shortcut. The shortcut is, this is the slope of our equation. The slope is 5. This is how much you're going to change each time. This is also another name of your common difference. The difference between each of these terms is 5. And you can even see that over here. Between 30 and 55, I add 5, which means I'm going to add 5 yet again, and I can get to the next value of 40 and keep adding 5 to get to 45. So the quick way of doing the table. In part B, we need to identify the the slope of the equation. Well, the slope here is equal to this number being multiplied by the variable. The slope in this case is 5. It is also known as the common difference. We need to interpret that equation. So in the context, whenever you see the word interpret, that means use what situation you're talking about and say, what does this thing mean? What does 5 mean? Well, 5 is how many more chairs you have whenever, so let's see, n is the number of chairs. So n is the number of chairs. Oh, sorry, n is the stack of n chairs, right? And then h is the height in inches. So if I have 3 chairs, my height is 40 inches. When I have 4 chairs, my height is 45 inches. The slope of 5 means each additional increase in chairs gives us an increase of 5 inches. So I'm going to write that out. 1 increase in chairs gives 5 increase of inches. And that's where that 5 came from. That's really 5 divided by 1, which is just 5. All right, number 6. A local restaurant is trying to recruit new employees. As an incentive to work there, they are offering a hiring bonus. In addition to their hourly wages, new employees will receive a one-time pay bonus. The equation y equals 200 plus 15x gives new employees total pay y for working x hours. How much is the hiring bonus? Well, think about it this way, right? If you start working there and you're like, I want that hiring bonus really bad, and then you end up not working there, you work a total number of 0 hours, then I can plug in 0 for x, and I can get just the hiring bonus, and the hiring bonus will be just that 200, because this will be 0 times 15, which is 0, and I just get the hiring bonus of 200. So 200. And this is when you work 0 hours. I was about to write 0 in words, 0 hours. Great. And then this is now asking, how much does the employee get paid for their hourly wage? Well, every time that I increase 1 hour, I get paid more wage. So what is the thing that is being attached to x that you multiply by x? In this case, it's going to be 15. So it's going to be 15, I can write $15 per hour. How do I know that? It's the number multiplied by the hours. So your hourly wage is being multiplied by however many hours you work there. So in this case, 15 was being multiplied by the hours that we were working there. All right, number 7. Luke gets pizza delivered from his local pizza shop every Thursday. This week, he ordered 3 pizzas for his family and spent $32.75. Last week, he ordered 4 pizzas and spent $41.50. Assume the price of pizza is the same. Does the pizza shop charge a delivery fee? Well, we'll see. We can figure that out by delivering 0 pizzas. What happens if they deliver 0 pizzas? They probably have just the delivery fee without any fee for the pizzas. So how are we going to do that? The way that I'm going to do that is I'm going to set up an equation and look for a y-intercept. That y-intercept is essentially the delivery fee. So I'm going to do it this way. I'm going to say y is equal to mx plus b. If I figure out b, that will be the delivery fee. To find m is going to be equal to the change in y over the change in x. So the price is the outcome of affecting the input of the pizza. The pizza in this case is going to be x. So I'll say pizza is x, and then the amount spent is the y. So we had $41.50, and if I subtract $32.75, I'll find the total change in the price, the total change in the y. For the x, the thing that we do have control over, we can control how many pizzas we have. We can't control how much it costs. Like, that's a set amount. And that's going to be, I had 4 pizzas for $41.50, and it was 3 pizzas for $32.75. So the bottom of this fraction is going to be 1, and I can just do the top of that fraction, and what is that going to be? I don't like subtracting decimals, so what I'm going to do to this is I'm going to add, so my problem right now is 41.50 minus 32.75, and instead of borrowing, I'm just going to add $7.25 to both of these, and this is going to turn into a new problem that is much easier. This is going to be $48.75 minus $40 even. And you can clearly see now this is going to be $8.75. So this is going to be $8.75. So if I keep subtracting $8.75 over and over and over again, I can kind of fill out a table here. I don't have enough room, so I'm going to do it down here. With 0 pizzas, 1 pizzas, 2 pizzas, 3 pizzas, and 4 pizzas. I think this is going to be enough room. For 4 pizzas, we knew that it's going to be $41.50. For 3 pizzas, it's going to be $32.75. And I can keep going backwards and backwards. Every time that I move 1 step backwards, I am going to subtract this $8.75 because that looks like the cost per pizza. This was the total change in price, the total change in pizza for a units of price per pizza. All right, so I'm going to go backwards again, and I'm going to subtract $8.75. And I can subtract the 75 from 75 really easily. That's 0, and 32 minus 8 is 24. So this is $24 even, $24. Ooh, I want to do this in red, though, so I keep my colors all straight. $24 even. And then if I subtract $8.75 yet again, subtract $8.75, that's going to give us something that's close to, I mean, essentially I'm subtracting 9, which is going to turn this into a 15. So this is going to be $15, but I subtracted 25 cents too much, so let's add that back on, $15.25. And then if I go backwards yet again, if I subtract backwards again, this is minus $8.75. It's going to be something I can already see the pattern. It goes 50, 75, 0, and then 25, 50, 75, 0. So this one is going to be something .50, something .50. Ooh, I want to do this in red though. This is going to be .50, and you can generally see that we're going backwards about $9-ish dollars. So this is going to be $6.50. It looks like $6.50. So that means that if I don't buy any pizzas, then I have to pay $6.50 just for them to come to my door, and then every additional pizza is going to be an additional $8.75, which means oh, and it was asking for an equation anyway. Well, I was setting out to do an equation. I'm going to end up doing it down here. My equation is going to be Instead of y and x, I'm going to use d and p. So I'm going to say d is equal to px plus, I don't know, the delivery fee. I'll just say the fee. So in this case, I'm going to say the delivery is going to be the number of p pizza. Oh, so it's not px. It's mp. Sorry, that was incorrect. It's going to be the slope times the number of pizzas plus the fee. So the slope in this case is going to be $8.75 times the number of pizzas plus the fee, which is going to be $6.50 just to show up. So there's our final equation right there, 8.75p plus $6.50. All right. I didn't really answer A though, did I? I said it out loud, but I didn't write it down. Yes, $6.50. And the way that I figured that out was by doing my table down there where I actually had some room. All right, and number 8, the table shows the linear relationship between x and y. Write an equation for that relationship. All right, so again, I'm thinking all the way back to problem number 1 where I had y is equal to mx plus b. I need to find m, and then I'll find b. M is going to be the change in y over the change in x. So I just need to choose 2 of these, and I should be done. I'm just going to choose those 2. So I'm going to choose the change in x. Well, x did not change. And the change in y changed by going up 5. To get from -2 to +3, we went from here to here was +5. Again, I didn't change between 3 and 3, so that's +0. All right, 5 divided by 0. Wait a second here. We can't ever divide by 0. Whenever we divide by 0, that's like infinity. That's undefined. Okay, well, that means I can't do any sort of y equals mx plus b. If I'm undefined, that means I have a slope that's basically infinity. That means I have a vertical line. So this is a vertical line. And instead of having y equal to something, because normally like y is equal to 2 or any number for that matter is going to be a horizontal line. In this case, I have a vertical line, so instead of y equals 2, this is going to be like x equals something. So I know my final answer is going to be x equal to some number. I just don't know what that number is. And I think a good takeaway is, hey, what number is x? Well, this x is 3. So the answer here is x is equal to 3. Another way to solve this problem is you could have just graphed these points, right? If I were to graph these points, I have 3, -12, 3, -7, 3, -2, 3, +3, and you say, oh, wow, that looks like it's going to be this line right here that happens to be a vertical line, and that vertical line is always x equal to a number, and that x passes through that x-intercept at x is equal to 3. All right, and there are no other problems, so that means that we are done with our homework. And let me zoom out on all these pages so that you guys can see. That concludes Algebra 2, Lesson 1.5 homework. Thanks for watching.